Good morning, Year 11s. This is hopefully to just get you guys up to speed with the engineering exam, which you're supposed to be sitting uh, quite soon. Now, I just want to wish you good luck because some of you have worked really well all through, year 10 and year 11. And I just want you to do your level best to try and get as many marks on this as possible. I just want to start by going through some of the knowledge or the core knowledge really that you're supposed to know when you go into that exam. This is what we should have gone through, and we have been doing this since year 10. The first one here we're going to look at is about development of or engineering development basically, and here we're just looking at obviously the three areas of engineering, which is the structural design, mechanical design and electronic design here. Now the focus with structural design is just understanding about the development of bicycles, which I explained to you before that every one of you would have used a bicycle before. So the exam board has used this deliberately so that you then are able to use your personal experiences in answering questions about bicycles. But it's just to do with how materials and technology have influenced the design of bicycles nowadays. We know there's loads of mountain bikes and road bikes now that are made from carbon fiber, whereas back in them days they were made using steel. So these new ones are very lightweight, so meaning the user or the rider can go quite fast actually than they used to back in them days. But also if they're traveling and moving around with it, it's not straining for them. It's easy to carry around and move around and travel with if people are doing competitions across the world as they do. But also when it comes to mechanical design, it's looking about theme parks, which I'm sure most of you would have gone to theme parks, and it's just looking really at how engineering has affected or encouraged the development of new roller coasters that we see nowadays. You can get roller coasters that go quite far or quite high and very, very fast, and this is because of, again, development of new materials and technologies that leads to these being built. But also there's the safety aspect as well, because obviously being on a ride that goes as high as some of the stealths go, they've got to be safe for people who are sitting on them. So it's about you communicating and discussing how you think development of new materials have encouraged the making of theme parks and rides. And also now the last one being electronic design is looking at mobile phones and smart technology, watches, phones, tablets and so forth and so on, how actually again materials, the new materials have influenced how smart technology works and function, and how it helps us really as society on a day-to-day basis. The second one, again, which we've gone through in length, is materials and their properties. We've looked at this, and we've used plenty of materials since year 10, where we're looking at obviously the metals, the ferrous metals, non-ferrous metals, knowing what the differences are and the different types of ferrous metals. We looked at plastic, thermoplastics, thermosetting plastics, and we know now in the examination there are some pointers that we look out for to know if a material is if a plastic is a thermoset or a thermoplastic. And some of it is, we know a lot of thermosetting plastics have got the word formaldehyde at the end, but also resin as well. Okay, a lot of thermosetting plastics are resin. So we've got urea formaldehyde, melamine formaldehyde, epoxy resin, which are some of the ones we've gone through. We also looked at smart materials, and we spoke in length about the thermochromic pigment. We talked about photochromic pigment that reacts to light. We talked about hydrochromic pigments, Uh, we also spoke about shape memory alloy that we find, used in braces, which some of you have got, and loads of other different materials. And we said about, a material is a smart material is the one that reacts to the environment, to the external stimulus. Okay, as we said, light, okay, temperature, water. There's loads of materials that reacts to those. And then we also talked about composite materials, which we said are the combination of two or more other materials. An example we used quite a lot in our discussions was Kevlar, carbon fiber, which we see everywhere, but also concrete and MDF, plywood. We spoke about all of those, that they are composite timbers, because they are not just timber in them. There is timber mixed with epoxy resin, which is a plastic based material. So the mixture of two materials then creates a composite materials. But also excuse me, we looked at the different types of properties that materials have, and we said, as engineers, what we do is we look at properties. If we make a product, we think about what the properties, or what properties do we want that product to have, and then we then go off and find the material. So we think about the properties before we can think of material, because they are important. They are what leads us to then having successful products. Now the third one here I just wanted you to look at again, which a lot of people haven't been doing quite well in, is the mathematical equation. Last year we did see in the exam they brought out Ohm's law, which we went through when we did soldering and we worked with electronic components, and we saw this question about Ohm's law. But also what came up when there was about estimating cost of material, which again you've done in unit 2 when you was redesigning the product. You had to estimate how much the materials would cost if you was to remake that product. Okay, so what I'd like you to do also is just to reference this and try and understand these equations and how to read graphs and measuring using a datum. We haven't done datums as yet, but I'll talk about it in a moment. The other one that we might see coming up is this one here about areas of volume as well, that you need to be looking at. And you all know now that we use a metric sort of unit of measurements. We use millimeters, meters, and centimeters. We don't use imperial, which is the old one where we use feet and inches in engineering. Gone are the old days. Also, what we looked at was the processes. We've all used all of these processes, or most of them really, when we're making components in product design. We looked at obviously marking out is the first thing we do, cutting using different types of tools, and understanding for these processes what sort of tools are needed to complete these processes successfully. We talked about finishing techniques, that metals, materials like metals, ferrous metals, mild steel, which we've used, it does need finishing, and finishing is the last process that is applied to a material at the end, or a product, to try and get protect it or to improve its aesthetics. Now here, when you've been asked about finishing techniques, then you could be talking about things like knolling, which we've done to aluminium to increase, to improve aesthetic looks of those thumbs locking screws. We can paint, we can wax, we can polish materials, and so forth and so on. But the other one we look at is about shaping, which we're using things like files to shape materials. We've done drilling and turning, which a lot of you here, it was quite interesting, was the first time you guys did turning, and we turn using the lathe machine, or the center lathe, which some papers or people refer to as. Okay, and turning is basically reducing a material from a certain thickness to a smaller thickness. For example, when we're making the quick release pins, we reduce them from 16 millimeters to 8 millimeters using this process of turning. We haven't done brazing, because we haven't got the equipment for brazing, but we looked at obviously joining material like soldering, which we did some electronic components, and we soldered, but also plumbers do solder copper, okay, to to join two pieces or more than two pieces of copper together. They use the process of soldering, which uses heat and a soft metal called solder. We also looked at permanent and non-permanent way of fixing materials together, and we looked at things like nuts and bolts. We looked at pop riveting, which we had experimentation of, but also these ones are for metal, but also plastic to plastic. You can't use PVA to join plastic to plastic. You use things like epoxy resin to join plastic, epoxy resin here to join plastic. So which ones are there, how do you know if a joining technique is permanent or it's temporary? It's because if it's permanent, then for you to remove those or separate the two pieces, you've got to somehow break them. And then the next one here, sorry about this topic here, we shouldn't be looking at that one here. It's from the old from the last slide. But the other thing we looked at is this topic about processes, describing application of engineering processes, just you being able to know what processes are used for removing materials. We looked at drilling, turning, filing. It is ways, cutting. There are all ways of removing materials. And then obviously we've just spoke about joining and manipulation, joining and assembling components, whether temporarily or permanently, and heat treatment here. And we haven't gone through heat treatments in length, but we did give an example about heat treatment is used to improve strength of materials. Okay, it improves strength of material. Now, one that we looked at was the one that is called quenching, and we said what happens here is you heat metal to very, very high temperature, very, very high temperature. You don't want it to melt, but it just reaches that high temperature, and then you drop it in cold water, and that process is called quenching. But we also have another process called annealing, which you'd heat your metal to again high temperature, but this time rather than dropping it in cold water to quench, you just cool it slowly. Okay, you just cool it very, very slowly. And some of these process cooling, it takes time, can be prolonged, but they cool it to an extent that sometimes it reaches the temperature that it was before being heated, or they want the temperature to drop even further below than the material was before it was heated. Now, these treatments are called heat treatments, and they are to improve strength and to harden materials as well. Okay, to make the material even harder or stronger than it was. And then the next thing we looked at was this topic here about keeping safe in the workshop. Sorry, 4D, and then 5, keeping safe in the workshop. And we looked at a lot of risk assessment. We did identifying risk in the workshop and suggesting ways of avoiding those risks happening. Identify appropriate quality control measures as well. Now, when it comes to this next topic here, which is about engineering drawing, we looked at sectional drawing, which I've given you handouts. And sectional drawing really is where it shows if a piece of item has been cut. How do you identify that piece has been cut, and how do you show if where a saw blade has gone through? And you do that by shading it to show where the saw blade went through. Okay, so we looked at sectional viewing, We looked at center lines, hidden detail lines, and where we're saying in orthographic projection, if you know there is a line, for example, if you're given a piece of item like this and there's a hole here, we know in that hole, if I look at this from this angle, I know where the drill went through, there would be lines there. And we show that by showing hidden details line, to show even though you can't see that line, those lines, there are some lines hidden somewhere on the inside, and that's why we talked about hidden detail here. Now, datum point here, we haven't touched on it, but datum point basically means it's a line of reference or a point of reference. For example, when we start cutting on the laser cutter, we want the laser beam to start on a certain point of a material that we're cutting, and that point there is called as a reference point. The point where it then starts and cuts from, or whatever it might be cutting, is called a datum point, okay? Or what we might call as a reference line as well. If it's a line where components or lasering has to start, we call it a reference line instead. Okay, so we're going to start off by doing an exam question. Again, this one is about looking at developments of technology, the influence of engineering in the development of these smartphones and smartwatches. Now, I'm just going to give you about 8 minutes for you to attempt this question on your own, and then we'll get back to it and do it all together. So when you're ready, please stop the PowerPoint now to attempt this question. So 6 to 8 minutes would be enough to complete this question. Okay, so make sure you've got a green pen so we can go through this together. Now the question here says, the world of engineering is greatly influenced by development of technology. One area that has seen many changes in the use of smart wearable technology. Your task is to discuss 3 significant technological developments that have contributed to the development of watches similar to those shown above. Now, first thing you're looking at is 3 technological developments is what you're looking for. To answer this one, I would list those 3 significant technological development. Obviously we're looking at smart materials, obviously, because if it wasn't because of the smart materials on those screen, we wouldn't be getting anything like touch screen. Sorry, we won't be able to use touch screens on this mobile phones. But also what we know at the bottom here, there's a technology that allows you that infrared or laser that we use. Sorry, this is getting let me delete this. That allows to gauge and measure your heartbeat and so forth and so on. So this is what will come up. So obviously being able to connect mobile phones over to watches has meant it's been a great change in how we use watches nowadays. Okay, you don't have to try and pull your phone out when it's ringing. You can just answer through your watch. We know that, but we also know that the user can look back at their progress on the applications or on the Bluetooth or Wi-Fi. So we know, again, you don't have to use your phone. We can see how you've been working out all day, how many steps you've done, just by looking at your watch without having to necessarily use your phone. There's GPS as well that has been used, okay, that you can use with this technology, which then records your movement. Really, some sports people do use this. If they're playing football on the pitch, they can use the GPS technology to see how far and how much they're running in that pitch, and which area of the pitch they're spending most of the time on. Okay, and then we've got there where the user can track their routes accurately, and know, it's telling you, you need to start walking, you need to do this, so you're able to track and see how much you've done in a day, without necessarily having to write it down. It does it for you automatically. But also development of physical tracker apps, which we know, as we've just said, is what most people now use, for either sporting activities, and things like that. So if you was to give, obviously this is a 6-mark question, your requirements really is to list in bullet form 6 technological development, or 6 ideas really that you think have led to this. Then you are forcing here for anyone marking your work to give you a point for each one of those points you've included on there. But also you could just give 3 points, 3 main points with examples underneath. Okay, example, example, example under each point, and then you will get a mark for the point, mark for the example, mark for point, for example, just like that, which then all adds to 6 marks at the end. So let's go off and attempt this next question. Again, this one is out of 10 marks. So again, I'll be looking to see at least 10 points, or 5 points with examples next to them. We're not trying to write in an essay form here, okay? As long as you've listed your points, even in this way, I find it gives whoever is marking your work opportunity. They cannot, okay, miss that opportunity to give you a mark for whatever you've put down. So you've got to force whoever is marking your work to give you a point on that. So it's a 10-mark question. I'll give you 10 more minutes, or about 10 to 12 minutes to do that on your own. Okay, so let's go through the answers. So what I'll do here is I'll come up with the advantages first, because it's asking me the developments in technology over recent years have had an impact in society. Below are pictures of some electrical cars. Discuss the advantages and disadvantages of using electrical cars. So the first thing here we've done is selected the advantages. If you do 5 advantages, then you are guaranteed 5 marks. And then, for example, you go health and safety consideration during collisions. And what we're saying here is, because these cars, and what you could do for yourself actually, is give an example of what you mean here. So here we're talking about things like having sensors and cameras in the cars. Okay, has meant that these are more safer than the old cars that never had any sensors. So that would be 1 day or 2 marks for giving examples. These cars can also connect to interact with smart technologies such as your phone, so you don't have to pick your mobile phone up when it's ringing. You can just answer straight through the car, which makes it again safe for people driving. Okay, and things like lower cost of driving, because obviously they use electricity, which costs less than fuel, and you can refuel them at home. You don't have to rely on trying to get to a petrol station to be able to fuel them. Now the next point here we're going to look at is the disadvantages, and you can talk about unknown processes for battery removal or charge. This is the one that everyone is worried about, that what happens if the batteries die, or what am I going to do with my car? And I guess everyone is thinking about the same issue. But also energy cost to charge has increased, so a lot of companies now, energy companies now know everyone is now starting to buy electric cars, so they're starting to increase the prices of electricity, so that they can be benefiting as well. And then this one here about initial purchase cost, we know they're quite expensive, normally much more expensive than fuel or petrol cars, which again is putting people off. And again, another worry there is where you need to plan your journeys, obviously, because you need to be looking for charging points. There's not many charging points around the country, so you need to be planning your your journey every time, because you need to stop at some point to charge your car. So literally, you just look at this, think about personal experiences and think about reality or the life we live in now. When you answer this question, it'll make it much simpler for you to be able to be successful in gaining as many grades as possible on these tasks. So now we're going to move on to tools. Again, this is a question that comes up quite a lot in the exam, where you asked to name tools and explain their uses. We've seen quite a lot. Last year it was the digital calipers that came up. We've had soldering irons, tin snips, and so forth and so on. So you need to be able to know these tools. So for now, I've just listed a few here that I just want to see if you can remember, or if you know. Okay, so I'm just going to give you about 6 minutes for you to answer those. When you're ready, pause. And here's the answers. This here we haven't done. Okay, we haven't looked at. It's called a micrometer. It's like a digital caliper really, but it's used by engineers to measure very small object, or very small measurements. Okay, it's called micro for a reason, micrometer or micrometer, and it's for those sort of very small, minute measurements. We've used the line bender, nulling tool on the lathe. We've used a die and a tap quite a lot, but what I'm expecting for you to know by now is the difference between a tap and a die. I do not want to see in the exam people naming this together as one thing, tap and die. You need to know the difference between the two. A die here is for external threads, and a tap is for internal threads. Okay, and then obviously we talked about the external calipers. If you're trying to measure a cylinder, you use this external calipers to measure the outside of a cylinder, or you could use the internal calipers if you're trying to measure the inside of an object. Okay, so you just place them on the inside and you'll be able to measure that distance from the external calipers to give you that. And then obviously the last one we haven't used very much is the divider. You use a compass anyway in math, so it works in a similar sort of way. So please, on this one here, it's about health and safety. Again, it comes quite a lot, where you might be given an equipment or a machine and you're asked to talk about the health and safety risks and control measures for when you're using these machines. So it's just about you understanding, health and safety precautions really when you're using this equipment. And last year we talked about PPE, which a lot of people thought it meant the exams, but this one here, it's about personal protective equipment. Things like wearing goggles, it's a PPE, it's a personal protective equipment, and that's what you expected to be using when you are in the workshop. Okay, and then again here, safety signs and symbols. What do they mean? What are they telling you when you find them in the workshop? So I'm just going to give you again some time to go through those on your own and see if you can answer the questions. Okay, so I'll give you shall we say 6 minutes again to get that done. When you're ready, please pause the video.